This is the Earth Science Classroom. Welcome back to the channel. This video is all about our oceans. If you look at a globe or any kind of satellite imagery of our beautiful planet, you'll notice that it is mostly ocean, about 71%. And you might think the oceans are just still and flat and not moving. However, that is far from the truth. There are massive highways of fast-moving water circulating in our oceans, and this video is going to discuss what these fast-moving currents are that exist in every area of our planet's oceans. Today, we're going to look at oceanic gyres. So in this video, we're talking about oceanic gyres, which is global circulation of water, ocean water, saline water in the ocean basins. Now, this flow of water is a consequence of various factors, including the continents, Coriolis Effect, and the prevailing wind patterns. So first, the continents. The location and position of the continents tectonically and the shape of the coastlines dictates the flow of this circulating water around the ocean basins. It also dictates how fast they can move, and also the direction, how they link and connect up to form a circulating pattern called an oceanic gyre. Then you have the prevailing wind patterns. Now, wind is a consequence of differential heating across the Earth's surface, warm, hot equator versus colder or cooler higher latitudes and polar regions, and the movement of heat through the atmosphere causing low and high pressure to form in the lower atmosphere is going to create wind moving between this high to low pressure to equalize the atmosphere and maintain the flow of air molecules, which results in wind. The stronger the wind, the more effect and friction it will have on the upper layer or the Ekman layer or surface mix layer of the ocean. So the stronger the wind is going to blow and the longer it is going to blow for, then the more effect and friction it will have on the ocean surface, creating more winds, which is called swell, and the distance the wind is blowing is called fetch. But this all creates this prevailing wind, which results in these ocean currents, which form this large circulating mechanism that we call an oceanic gyre. Now, you add on to that the Coriolis Effect, which is the rotation of the Earth on the axis, which is going to have an effect on the liquid and gases, so the atmosphere and the ocean, in terms of the way these states of matter, both gas and liquid, are going to be deflected based on the location. So in the northern hemisphere, they are deflected a certain direction versus the southern hemisphere, they're deflected in a different direction based on the speed of rotation of conservation of energy. And this is amplified with the higher latitudes. So go towards the north and south pole, the Coriolis Effect is amplified and increased, whereas around the equatorial regions and the tropics, there is minimal Coriolis Effect because of the shape and spin of the Earth. So we've established that an oceanic gyre is a large-scale flow of circulating ocean water around each ocean basin caused by a mixture of the placement and location and shape of the continents, the land masses, the prevailing winds, and the Coriolis Effect, which is a direct result of the Earth spinning, rotating on its axis, and the shape of the Earth itself being an oblate spheroid. Now, an ocean gyre can be broken into sections or components. They are the boundary currents and the transverse currents. Now, if you imagine or picture an ocean gyre as a four-sided geometric shape, a square or rectangle, you will have basically four sides, two of which either side are parallel to each other on opposite sides is the boundary currents going north and south, and the ones that connecting the boundary currents going from east to west or west to east is going to be the transverse currents. Now, the general flow of these ocean gyres is based on which hemisphere you are, either north of the equator or south of the equator. Now, this is down to the Coriolis Effect and the resulting wind and flow of water caused by the rotation and deflection of air and water by changing the speed of that air and water, which results in the northern hemisphere gyres circulating in a clockwise direction and the southern hemisphere gyres circulating in a counterclockwise direction. This is the Earth Science Classroom. Thank you for watching the video. I really appreciate it. And if you get a chance to like and subscribe, that stuff really helps the channel. Thank you so much. And see you again in a future video.